Okay, so here we're dealing with polygons, and we're dealing with angles in polygons. So we need to remember a couple of rules. And polygons are shapes made of straight sides. Two types of polygons really. The regular polygons, all the side lengths are the same and all the interior angles and exterior angles are the same values. Or irregular ones where there could be different interior and exterior angles and different lengths. So we have an interior angle, and when we extend the side and turn to go down the other side, we then create what's called the exterior angle. Now for regular polygons, there's quite a quick rule for the exterior angle. It's 360 degrees divided by the number of sides, so n is the number of sides. And the other quick rule is that the two angles at the vertex where the two lines change direction, they're on a straight line, so they must add up to 180. So we say that the interior angle plus the exterior angle equal 180 degrees. That rule actually works for all polygons, whether they're regular or irregular. This one only works for regular polygons. So those are the two main rules to work with. There are other ones, but if you learn these two, you can generally do every other question just by logic. So it says work out the size of each interior angle of a regular octagon. So octagon, 8 sides, so that's telling me n is worth 8. I want the interior angle, so that means I want that inside angle there. Well, I have a rule that tells me how to calculate the exterior angle. And once I've got that, I have a rule that tells me how to get that. So the first thing I'll do is work out the exterior angle. And that's going to be the 360 divided by 8, because the rule says 360 divided by the number of sides. 360 divided by 8 is 45 degrees. So that's the exterior angle, but the question wants the interior angle. And we know the interior angle plus the exterior angle is 180. So we're going to take away 45 degrees from there, and we're going to get 135 degrees. So that angle is going to be 135 degrees because this angle was 45 degrees, and angles on a straight line add up to 180. The next part of the question says the size of the exterior angle of a regular polygon. So in other words, we've got a straight-sided shape doing this. We're not sure how many sides it has, but we do know that this angle here is 30 degrees. So that means that this angle here would have been 150 degrees if we needed to know it. It says work out the sides, the number of sides of the polygon. It's told us it's a regular polygon. So we have the rule for regular polygons that exterior angle equals 360 degrees divided by the number of sides. Well, they told us the exterior angle is 30 degrees, so we know that 30 degrees is 360 divided by the number of sides. So in other words, 360 degrees divided by 30 must equal the number of sides. So that equals 12. So it's a 12-sided shape. Reason why we knew we was going to do this sum is we're basically saying we must have got 30 by doing 360 divided by this thing. So if we find out how many 30s are in there, then that must tell us the end value. So we end up with 12 sides. So with polygons then, we just got to really remember these two rules. Then by logic we can work out everything else. And exterior angle for a regular polygon, 360 divided by n, and so forth. If you've got an irregular polygon though, so if we had an irregular polygon, so something that had nothing the same, no angles, no lengths, or could have two lengths the same, etc., but something's different about it. There's nothing regular, not everything's the same. Then there is one other rule that you need to remember, and that is the sum of the interior angles equals n minus 2 times 180 degrees. Now that works because any polygon can be split up into a minimum number of triangles, and each triangle, the angles add up to 180. And to work out the number of minimum triangles that you need, then you always take 2 away from the number of sides. So for this pentagon, 5-sided shape, I can see here I can create 3 triangles minimum by just connecting diagonals. 5 take away 2 is 3, and then times by the 180 for all the angles, and then that will tell me the size of every interior angle added together. So this is another rule for any polygon if the question talks about the sum of the interior angles. So that's polygons and angles within them, or exterior ones outside them.